Hello guys, welcome to Clearning with new video. In this video we will learn about basic configuration of BGP, how BGP work, and how in BGP in different autonomous system work. So let's go toward the configuration. So this is I have create 3 autonomous system. So this is autonomous system number 200, this is autonomous system number 300, and this is autonomous system number 100. So first of all we complete layer 1, and we do the routing in individual route autonomous system, and then we configure BGP, and then we communicate different autonomous system with one another. So let's go toward the configuration. So first of all, in this autonomous system, I give the IP address in system view, interface loopback 0, IP address is 10.10.10.1 and 24. This is the loopback. Now we go in interface giga 0/0/0, and then the IP address is 10.10.10.2 and 24. Sorry, IP address. Okay, this is not 10, this is 20. So let's go toward the loopback interface loopback 0. So IP address is 10.10.20.1 in loopback, and 10.1 here in interface G 0/0/0. IP address is 10.10.10.1 and 24. Sorry, 10.2 and 24. So display this. You can, by display this, you can see what IP address I have configured, 10.2, which is here 10.2. So there is no need of configure any routing protocol, because they are directly connected networks, so they will be reachable. So now in this interface or in this autonomous system we do the same. First of all, we give the loopback 0, and the IP address of loopback is 20.20.10.1 and 24. Now we go in interface G 0/0/0. IP address is 20.20.20. and 20.2 is here, and 20.1 is there. So above we configure 20.2. so here again we don't need to configure any routing protocol, because loopback and this interface is directly connected, so both will be reachable. So now we configure here in this router. First of all, I will give the IP address. So now you can see here is interface G 0/0/0. IP address is 10.10.10.1 and 24. Now we go in this interface G001, interface giga 0/0/1, and IP address is 192.168.10.1 and 24. Now we go in second router. In this router, in system view, interface G 0/0/0, and on this interface we'll give IP address 192.168.20.2 and 24. Now we go here in 0/0/1, and IP address is 192.168.10.2 and 24. Now here on this router, system view, interface G 0/0/0, sorry 0/0, and the IP address is 20.20.20.2, sorry 1 and 24. Now on 192.168.20.1 and 24. Now you can see here, this is a separate autonomous system, this is the separate, and this is the separate. And in this autonomous system 100, there 3 router exists. So 3 routers should be connect to each other and reachable to each other via a routing protocol. So we configure here a routing protocol. Now we use OSPF routing protocol. So we configure this interface and this interface in routing OSPF routing protocol, so these router will be reachable to one another. So we do not add this interface of a router in OSPF, because this interface is connecting this area, this autonomous system, to another autonomous system. So on this interface we configure BGP, and this interface we configure OSPF. OSPF is a interior gateway routing protocol, so OSPF will communicate with this router with the neighbor routers, and BGP will configure on this interface, and BGP will communicate this autonomous system with another autonomous system. So remember one thing, if now when we configure BGP, so we configure BGP on this interface, and on this interface we configure internal routing, IGP routing protocol. So now we configure OSPF here, OSPF1 area 0. Now okay, we keep all this in area 0. Suppose this is area 0, so I will write here OSPF area 0. Okay, area 0. Okay. Now area 0 and the network are 192.168.10.0 and 0.0.0.255. Same network will configure on, we will copy, and this is the now here as well. So OSPF, put OSPF 1 area 0, and the network would be the same, this 10 dot network, and also the 20.0's network, 20.0's network. So you can see here the neighborship is going to up in each state, in two-way state. These two router are creating neighbor relationship and exchanging their states. So here as well we go in OSPF 1 area 0, and the network would be the same 20.0's network. Now these two router also exchange their state and go in their full state, then their router will be able to communicate with each other. Now we will ping these two router. So ping, if I want to ping this, it will be reachable 168.20.1. so after some time, when their neighbor their state will be exchanged and their packet will be exchanged, they will be in full state. So still they are in two-way, after some time they will be in full state. So access start, now they are in full, so they will be reachable to each other. Now you can see here, but this router will be reachable to this router, but this from this autonomous system to this autonomous, they will not be reachable, because they need a separate routing protocol, which is the BGP. So we configure BGP. So to configure BGP, there are two types of BGP: eBGP relationship and iBGP relationship. In eBGP relationships, eBGP relationship are created between different autonomous system. Suppose we are creating BGP in this, from this autonomous system to this autonomous system, so we create a eBGP relationship, exterior BGP, which is called exterior BGP, eBGP relationship. Okay, and between these routers we also create iBGP relationship with the neighbor router in a same autonomous system to create the full adjacency. Okay, so we create, because we create a peer with one another, so we also create. So in this router we create a iBGP relationship, because we tell this router this is the area border router or autonomous system border router, sorry, autonomous system ASBR, and this is also a ASBR router. So we have to tell the router that what are your peer in different autonomous system and what are your peer in same autonomous system. We are, so this is the BGP relationship, full BGP relationship. So now we go here in this autonomous system. So now let's go toward the configuration of BGP. So system view and BGP, what is the area is 200. Now we are in area. Now we give the router ID. So router ID we select with the router this name R1. So router ID is 1.1.1.1. Now we select the peer. So there are no peer iBGP peer in this area autonomous system, because this autonomous system contain only one router, so there is no iBGP relationship. But this autonomous system contain three routers, so iBGP relationship created between these three routers. So here only eBGP relationship will be created. So now we go here. So BGP router peer, and what is the peer ID? So we select the peer IP address. So peer is this autonomous system and this interface, so we give this interface IP address. So peer is 10.10.10.1 and autonomous system. We also have give the autonomous system number. So in which autonomous system this peer exists. So autonomous system is 100. If you give the 100, so it means this is the iBGP eBGP relationship. If the autonomous system number same would be same, if this is the 200 and here we also write 200, it means that this is the iBGP relationship. The autonomous system number is same as in VR, so this will be the iBGP. But this here the autonomous system in which we are and the autonomous system of peer is different. It means that this is the eBGP relationship. So this is the eBGP relationship. Okay, we write the peer. Now we also create peer here. So first of all we create eBGP peer. So BGP 200, sorry 100 we are in BGP 100, and now we define the peer here. Peer is 10.10.10.2, which is this one, and AS number, what is the AS number of peer? The AS number of peer is 200. So this number is 200, so it's the 200. We also have the iBGP peer here. On this router we have this iBGP peer and this iBGP peer within same autonomous system. So we also define peer in a same manner, iBGP peer in a same manner. So peer name is peer IP is 192.168.10.2 and the AS number is same 100. So this is the iBGP relationship. We also have another peer which is this one, and we write the peer IP address 192.168.20.1 and AS number is same 100. So this we create the iBGP peer. So now we go here, we also define the peer of this router on this router as well. System view BGP 100 and the peer are 192.168.10.1 which is this. For this router is a peer router within same autonomous system 100. And also we have 20.1, this is the 20.1. also we have 20.1 within same autonomous system. This is also the peer. Now we go here we create two peer. One is the iBGP peer, which is this peer, and other is the eBGP peer, which is this autonomous system. So now we go in BGP, in system view BGP 100, and we have a, sorry, we didn't give the router ID here on previous router as well. Router ID, this router ID is 4.4. It's not important, but it's good practice to give the router ID. So now we go in BGP. Now we are in BGP. Now we create a iBGP peer first, 192.168.20.2 which is this 20.2 and AS number is 100. Now we create a eBGP peer 1 which is this one, eBGP 20.20.20.2. So 20.20.20.2 and AS number is 300. The peer exists in AS number 300. Now we create the eBGP here as well. Now we go here and do the same. We create in this interface, we only create one peer, which would be the eBGP between different autonomous system, exterior BGP peer. So BGP 300 peer is 20.20.20.1. so 20.20.20.1 and AS number is 100. AS number is 100. And you can also give the router ID 5.5.5.5. so now we define the peer with one another. Now you can see here with the command display BGP peer, so you can find the BGP peer. So you can say the peer is 10.10.10.1 which is this, and AS number is 100. The peer's AS number is 100. So now on this interface or on this router we also see the display BGP peer. So you will see here, so you can see here the peer is 10.10.10.2 which is this one. So peer has been established. So their state has been exchanged, their packet has been exchanged. Now they are in established state, so it means that they are in full peer state. And another peer is 10.168.10.2, which is this one. And the peer has been established on this interface. This peer 20.1 still in active state, they are not established yet, they will be established after some time. So because this is not established, you can see the reason. I forgot here to give the, to tell him that you also have this peer and also have this peer, so that's why this is in active state. If we go in this router, so we also define a peer 192.168.10.1, which is this one 10.1, and AS number is 100. Now they will be in established state. So now you will observe here, after some time they change into established state, because in both sides we tell that these are a peer. So 10.1, okay, after some time they will be in display BGP peer. So you can see here 10.1 is still idle. Now their states are up, and then they will exchange their state and they exchange their packet. After some time they will be in peer state, established state. Now we go toward the networks. So now we just create a BGP peer, still we do not give the network. We didn't define the network in BGP. Still there is no configure reachability would be exist 10.10.10.10.2. So because they are directly connected, so there will be reachability. From here this will not be reachable because they are not directly connected, as well as there is no BGP relationship exist. Ping 10.10.10.2. so you will see here this will not be reachable from here, because we didn't define the networks yet. From here it's reachable because this is the point to point, so that's why it was reachable. Now we go in interface and we define the network here. So how we define network? There are three types of defining network. One is the incomplete route, other is the network command, and the third one is import route. So we go here in this router, we are in BGP 200. If we go BGP 200, and here IPv4 family unicast, this is the command, and now we define here network. So there are two directly connected network, one this and one is this. So just we write the command. You can also write the command network and then define this network and this network, and one by one. And you also have other command that import route direct. If you question mark, so you can see here there are different route exist. If you write this command, it means that directly connected network will be imported in BGP routing protocol. If I show you display BGP routing table, so there is no route in BGP routing table. Now after this command import route directly connected network will be come in BGP routing table. So now if you display BGP routing table, so now you can see here there are two networks. One is 10.10.10.0 and other one is a 10.10.20, which is the loop back in BGP routing table. Same we do here, display BGP routing table. So there are no there is only one BGP route exists, which is the direct route. From here to here we create the BGP route. So this is only this one route exists, 10.10.10.1 and 10.10.20.1 coming from here. So no other route exists, so there would be no any reachability and no communication. That's why from here we can't able to ping this route or autonomous system, because this router's BGP routing table is empty. Display BGP routing table, so empty routing table, there is no network, only loopback network exists. So we create a BGP. If we ping 10.10.20.1 it not be reachable, because only this router learn this loopback address through this peer relationship, but this router does not know about this router, because this router didn't learn this network. You can see here, display BGP routing table, display BGP routing table. So this route does not exist in this BGP routing table, that's why this network will not be reachable. So we have to tell this router that you have OSPF network. So IPv4 family unicast, we go here in this command, IPv4 family unicast. Now we import direct route. If there are two ways to define this network, import route OSPF, so all these OSPF route will be import in this BGP routing table, import route OSPF 1. So this these route, these two route are running in OSPF. So if we import OSPF routes, so all the route come in BGP routing table. So now you will observe display BGP routing table. So now you can see here this route exists, 10.0 and 20.0, all route exist in this routing table. Also we have to give the this route via network command. So network 10.10.10.1, which is this network, 10.0, okay, 10.1 and 24, okay. So display BGP routing table. So now you can see here this routes exist, all route exist. Now you go here and also write display BGP routing table. So now you can see here all route exist here, 10.1. Now we go here, let's see is there any route exist or not. Now you can see here all route exist here, 10.2, 10.20.2, and other are 192.168, all these route, and 20.0 this route exist. So now they would be reachable to each other. Now you can see here this autonomous system loopback exists through this. Here we also tell this route system view BGP 100 and IPv4 family unicast. Here we then after this command we define the network. So import route OSPF, all this route will be import in this router's BGP. Still this BGP routing table, you can see here, because they are peers, so they share their routing tables, BGP routing table. So now we define here. So from here let's see this route exists or not. So you can see here display BGP routing table. So you can't see here this autonomous system loopback 20.20.10. or 20.20.20.0 does not, this route does not exist. Why? Because we didn't give any network here. So we go in this router system view BGP 300 and sorry BGP 300, and then IPv4 family unicast, and the network import route direct. So directly connected network will be imported OSPF BGP routing table, display BGP routing table. So only these route exist, this OSPF route, this loopback route, and this its own route does not exist in its routing table. Why these route are coming? Because they are peers with each other, that's why these route are coming in their BGP routing table, but their own network routes does not exist. So we import their route, import route directly connected, direct. So now you will see here display BGP routing table, all route will be exist here. So now you can observe that all route present in this routing table here as well. Here we will check, now we will check BGP routing table. So you can see here 20.20.10.1 route also exists, but 20.20.20. Does not exist. 20.20.20.0 network does not exist. Why? Because here we didn't give the network command, network 10.10.10.1 and 24. So now sorry, it's not 10.10. It's 20.20. Okay, undo. undo. Now network 20.20.20.1 and 24. Now you will see here this 20 route will be exist. Now you can see here this 20.20.20 route has been exist. So all the router, all autonomous system exchange their route. This autonomous system also contain this route. You will observe now. Now you can see here this one 20.20.10.1 exists here. 20.20.10. Which is the loopback, this one exists here. If you want to go on this route, you can see here you have to go through this next hop, which is this one. From here, if you want to go here, you have your next hop is this one, and you have to go in autonomous system 100, then you will go on autonomous system 300. So all these route are reachable from one another. Now we just go here in this display BGP routing table. So now you can see here 10.10.20.1, which is the loopback of AS200 also exists here. So now this route will be reachable from. Now you can ping if you want to ping 20.20.10.1, which is this one. So now you will see here this all route from this autonomous system. It routes going to autonomous system 100, then from here to here all are reachable. From here you can also ping. If you want to ping this router, it will be reachable. Ping 192.168 10.1. So there is a mistake. We didn't import. We only give the network command. We didn't import OSPF route in this routing table. Display import route OSPF. Oh sorry, OSPF 1. Now all the route also exists here. Now you can ping. You can see here OSPF route has been gone in this BGP routing table. From here to here all are reachable. So from here you can want to ping this, so you can ping 10.10.10.2. so this is the 2 reachable. Its loopback also would be reachable 20.1. so it is reachable from this autonomous system to this autonomous system. Both are reachable. So hope you like the video. So this was the concept behind the autonomous system and BGP. First of all, you have to complete the layer 3. So in respective autonomous system, complete layer 3 here, and if there are multiple router in this autonomous system, so run a routing protocol and communicate these routers. So after that you have to create the eBGP relationship between this route to this route, from this interface to this interface, and from this interface to this interface, a eBGP relationship. So after that you have to create the iBGP relationship, which are the on a same autonomous system, from this route to this route, this route to this, and from here on router 3 you also create the iBGP relationship. So from here its peer is this one, and also this peer, and from here as well you have this peer and this peer. These two peer are iBGP peer, and this peer is a eBGP peer. After peership, you have first step is to create the peer, make peer with one another. After that you have to define the networks. So while defining the network, you have different type to define the network. So here if you you can also write the individual network while network command. So write the network, this network, or you have option to import route direct. So directly connecting network will be imported. So here you can give this. So I use here that I just define this route with the network command, and this route with the import route OSPF, because all these route exist in OSPF. There is another way to do is that I write either here I write the command OSPF import route direct. So this route and this route are imported in BGP routing table, and after that I write import route OSPF. So there is no need to write the command network. So if you want to write, so there are different ways. After some time, after some practice, you will be able to understand. So these are the way to import the route in OSPF routing table via different commands. So this is the basic behind OSPF. Hope you like the video. So video has been little bit long, so thank you very much. Hope you like the video. Please subscribe.